Hi, I'm Macy with the Bard College Center for Civic Engagement, and today I'm going to show you 3 experiments that use fire to show us about how gases work. These experiments require adult supervision, meaning somebody who is 18 or older, and they are for older students, meaning students who are in 8th grade or above. For the first experiment, all you're going to need is a candle like this and a lighter. First, you're going to want to light the candle, and you want to wait for a layer of wax to form under the wick. You want your layer of wax to look something like this. Now I'm going to blow out the candle and then immediately have my lighter ready and put it right over the wick. The candle relights before you touch the flame to the wick. This happens because heat melts the wax, turning it into a liquid. The liquid increases the temperature and evaporates out of the top of the wick. When it evaporates, it turns into a gas, which stays in the general area around the candle. The gas mixes with the oxygen in the air, making the air flammable. Because the wick stays hot, the liquid continues to be drawn up through the wick and evaporate in a continuous process. Because the air around the candle is flammable, it is ultimately that flammable air that relights the wick, not the physical touching of the flame to the wick of the candle. For the next experiment, we're going to head to my kitchen. You are going to need a plate, a cup of water, a glass, a candle, a lighter or a match, and optional would be food coloring. You want to make sure that the glass you use is going to be taller than your candle. If your candle doesn't stand up in the plate on its own, you can light it and then drip a few drops of wax into the center of the plate. And then you can sit the candle in the wax, which should stick it to the center of the plate and allow it to stand up. If you're using food coloring, you're going to want to put it in a cup of water. I have pink food coloring right here. And then you can mix it in with a spoon or a straw or whatever you want. And then I'm going to pour this water into my plate. The food coloring just makes the water a bit easier to see. So then you're going to light your candle and place the glass over top of it. Your flame is going to burn, but eventually, after a few seconds, it's going to go out. Then you want to watch your setup for about a minute after the flame goes out. The water in the glass is going to be sucked up and remain at a higher level than the water on the plate. The reason that this experiment works is because the flame heats the air, which causes the molecules to expand. Some of the air escapes the glass, which is why you may see bubbles in the water around the glass. Then the flame goes out. Once the flame goes out, the air inside the glass cools, which thus takes up less space. That allows the water to be pulled up inside of the glass. Water is pulled up inside the glass because of a concentration gradient. What is a concentration gradient? Well, essentially, molecules like to travel from areas of high concentration to areas of low concentration. Essentially, they want space to breathe and stretch out. There was a higher concentration of molecules outside the glass than inside the glass. So thus, once there was more space available, the water moved up inside of the glass because it wanted space to breathe. The water stops rising when the pressure outside of the glass and inside of the glass is equal. In nature, an isotonic concentration gradient is ideal. That means that the concentration of molecules outside and inside of a substance is equal. A hypertonic solution means that there's a higher concentration of molecules outside than inside. That is how our experiment begins. The opposite of that is a hypotonic solution, when there are more molecules inside than outside. That never occurs in our experiment. It only reaches an isotonic solution at the end. Now for the final experiment, you are going to need 2 bowls of the same size, 2 glasses, one bigger than the other, 2 candles, and something to light a candle with, like a match or a lighter. If your candles don't stand up on their own, you can use the technique I showed earlier to get them to stand up in the center of both bowls. Now you're going to want to pour a small amount of water into both bowls, making sure that it's the same amount for each. And then you can light each candle and place the glasses on top of the candles at the same time. As you wait for the flames to go out, you will see that the candle with the smaller glass over it will go out before the candle with the larger glass over it. The reason that the candle in the smaller glass gets blown out first is because fire needs air, specifically oxygen, to burn. There's less air in the smaller glass than there is in the larger glass. There's still a little bit of air in the glasses after the fire gets put out, but within that air there is a higher concentration of other gases such as carbon dioxide and nitrogen, which fire emits. Thus, the air has a very low concentration of oxygen, forcing the fire to be put out. Thank you so much for watching. I hope you enjoyed these experiments and will try them out at home. Once again, I'm Macy from the Bard College Center for Civic Engagement.